Hi, in this video we will go over the steps that one needs to take to complete a substitution for an indefinite integral. Well, first thing to recall is the substitution rule, the way we wrote it. So it says that two integrals are equal. One is x integral, which is a bit complicated one, f at gx times g prime x dx, and then another one u integral. These two integrals are equal for any f and any differentiable g. And if you do it correctly, well, this new integral, which is u integral, is easier to handle, hopefully, and then probably you can evaluate that integral and find the result of the original integral. But, well, in practice, how or what steps you need to take? What are the steps? Well, step one, this is very important. You have to first identify the pattern. So identify the pattern well, of the left hand side. This is the integral you have been given. Integral, the integrand is a function composed with another function g, and the derivative of g is multiplied to that whole function. So there are two functions, f and g. F is evaluated at g or composed with g, and the integrand is not just FOG, but also the derivative of the inner one is there. That's the first thing. So you identify the pattern here and find what are f and g. So if you've done that part, then main part is done, but now you have to find the relation between u and x, the new variable and x, and du and x, and du and dx. Well, how this works, you will see me doing always this on an equality that goes from x integral to u integral. It will be u is going to be g at x, and du and dx are related through this kind of equality, that du is not equal to gx dx, not equal to dx, but the derivative of g times dx. So these are two things that you have to do. The third thing is that write down the u integral. The integral you started with is an integral in terms of x. Now we move to a u integral. So you change this f gx g prime x dx. So these two together is going to be du, and this part is u. So you replace this. This is substitution. You go to this new variable. Now, the fourth step is that evaluate the u integral. Well, whatever is that, hopefully it's an easy integral to evaluate, and then you will find a function in x. Well, we'll find a function, in u. This is what you do in that step, but you're not done until you do plugging back gx for u. So plug back gx in u the antiderivative or the value of the u integral, antiderivative of fu. So start with x integral, identify the pattern, then you will see what is f, what is g. Then find the relation between u, the new variable, and all variable x, and d of new variable and all variable x. Then turn your x integral into u integral. So you go from this to this new one. This is new integral. Hopefully it's an easy integral to evaluate. You evaluate it, and then everything will be in terms of u. You plug in back gx into u into your final answer. That way you're done with the substitution and you evaluate it. Let's do some examples here. Okay. Very nice. Here, I have integral of cosine x root sine x. So I'm looking for the pattern. See that there is a square root of sine x. That's probably f at gx. So this at gx. And then gx is going to be sine x in that case, root of sine x. Derivative of gx, derivative of sine x is cosine x. So that is what we have. We identified the pattern. The second thing is that set new variable u to be equal to gx, which is sine x. The du is going to be related to dx by multiplying derivative of sine x, which is cosine x, to dx. That's the second step. Now it's time to turn everything into u integral. Du dx times cosine x is du. So I will put du for this part. And here, f at sine x is u. So this will give us u to the power half. And this is 1 over half plus 1, u to the power half plus 1 plus c. And well, this gives me 2 over 3, u to the power 3 over 2 plus c. So this is you evaluated u integral, but you're not done, and you have to put back this gx for u. So wherever you see u, you put sine x there. Sine to the power 3 over 2x plus c. How about this one? Okay, nice. I see e to the power 3x. Okay. Well, you may say, okay, it is a little bit complicated here, which one I choose, but whenever you have e to the power something, that something is a good candidate for gx. Okay? And then the derivative of gx is constant, 3, yes? If you have constant derivative, don't worry about that. You can do a nice trick there. So by just looking at there, you see that now new variable, I can set it as gx. And the du is going to be, well, what's gx? 3x here. And du is going to be derivative of that, which is 3 times dx. And as you can see, there is no 3, the derivative of g multiplied to dx. But since it is constant, I can multiply dx by 3. And by constant multiple rule, I can put 1 over 3 outside so that they cancel each other. This way, you have du here. And we have e to the power u. Well, you have to be careful now. As I said, there's the friend here we have, he's going to tag along and we will continue with that guy up to the end. So x integral turned into u integral. Now evaluate this in the, what is antiderivative of e to the power u? This is e to the power u plus c. We are not done. We have to put back what was gx, original gx that we choose, back into u. So e to the power 3x plus c is what we have here. In this case, well, we have sine of something. If you have sine of a function, that function is the best candidate to do the substitution with. So gx is going to be cosine x, f is sine. But then you might say, what is the derivative of cosine x? Derivative of cosine is negative sine x. Well, sine x is here, but I can multiply a negative sign there and multiply a negative sign outside, and I can get g prime, almost g prime, yes, there, and that would do the job. So let's start with this guess, meaning that I can put u to be cosine x, and du in that case is going to be negative sine x dx. And how I'm going to generate that negative sign. Okay, I will do this. Multiply negative to sine. But since I don't want to change the integral, I will multiply the whole integral by another negative sign so that they cancel each other. Now, this piece is du. This is sine of u. So sine u. What is antiderivative of sine u? This is negative cosine u plus c. We are not done. You have to put back in what was your gx chosen to be. So minus cosine of cosine x plus c. I choose u to be cosine x. That's where I have that cosine come. And the last one, when you have e to the power some function, that's the best option to do the substitution with. So I will put u to be root x. Derivative of du, derivative of u root x is 1 over 2 root x dx, which is almost here. You see this guy is e to the power root x, 1 over root x dx. Well, we are missing a 2 here. Since 2 is constant, I can put in the denominator and well, multiply to a whole integral by 2. Just make sure that we have the correct or equal integral. From here, now we do the substitution. 2 comes with us. E to the power u, this guy is du. Antiderivative of du is e to the power u. And put back in u, which is root x, and that is what we have. So you have to follow these steps and make sure that you complete all of them and find the value of the integral.